Alright, so here we are with Unit 7, Lesson 7, and we're going to look at something called parts per million. Now, on the previous lesson, you'll remember that we talked about molarity, which is one way of expressing quantitatively the concentration of a solution. We're going to look at a second one, which is called parts per million. Parts per million, not really honestly asked about a lot on the Regents exam, so obviously you're not going to spend a lot of time studying for it, and anyway the equation is on your reference tables as you can see on the slide. I think it's easier just to go ahead and do a couple of problems. So you can see here it says approximately 0.0043 grams of oxygen can be dissolved in 100 milliliters of water at 20 Celsius. Express this in terms of parts per million. Well, let's take a look at this. If you look over here, here's the equation, the formula right here. Alright, so let's see what we got. Okay, so that's the amount of solute. That is grams of oxygen. And you'll notice it's 100 milliliters of water, but notice that it's not 100 milliliters, we've added the 100 and this. That's because the bottom is the mass of the solution, and the solution is both the solute and the solvent. So you have to add both of them together for the bottom number. So the mass of the solute is 0.0043 grams, not a lot at all, over 100.0043 grams of solution. Divide that, multiply by 100, and you're going to get 43 parts per million. If you look at the bottom one, let's see what we got. It says 2.5 grams of groundwater solution, so that is the solution. So it's ppm, and it's 2.5 grams of solution. Now you might be wondering, well, why don't we add this number to it? Well, that already tells us that's the solution, so that also already includes the water and our solute, which is the +2 ions. The top number is going to be 5.4 times 10 to the 6, so if you want to change that to a number that's not scientific notation, you're going to move the decimal 6 places to the left, so it's going to be going to have 5 zeros and then the 5-4. So it's 0.000054 divided by 2.5 grams, and then that would be times a million. And that's going to come out to 2.1 parts per million. And that's pretty much how you do parts per million. Now there are a couple other problems, equations for concentration. I really don't see the mass, the one about percent by volume. The percent by mass is one that we've already done. Percent by mass is the same formula, so I'm not really going to get into that. So that's it for this lesson.